Moving into a new chapter, chapter 4. Eventually, we're going to use this chapter to just talk a lot about how to buy a car. But before we do that, I want to take a look at some more statistics. And we're going to start by talking about what we call measures of central tendency. And this is just a fancy blanket term for a single number or value that best represents or maybe summarizes the data set. So it kind of answers the question, what would a typical value for this set of data look like? And there are three that we're really going to focus on, and they are mean, median, and mode. And these are hopefully terms that you're familiar with from previous math classes. So hopefully this is some review for you. So the first one is mean, and we can see two symbols sometimes to talk about mean. We'll see either this x bar, and we just read it that way as x bar, or the Greek letter mu. It kind of looks like a long U. And the mean is just the average, right? When we're used to calling it the mean, when we called it the mean, we just call it the average. Anytime I talk about an average of your grades, I'm usually talking about something like mean. And we know how to calculate this. We know that this is just the sum of all the values divided by the number of all the values, the number of total values in the data set. We actually just did this in the last chapter when we talked about average daily balance. Ultimately, that was just a mean. And that's the way we would calculate it, right? Add up all the values, divide by the number of values. Well, the issue with mean is that it's easily influenced by extreme values. And this is something that we like to look at a lot in statistics. Is this the impact of these extreme values on a set of data? For example, maybe I have a 100 average over 5 tests, and my 6th test I get a 0. Well, that's going to drag my average down a lot. So we want to know what happens when we talk about these extreme values, and we see that, right? It's easily influenced by extreme values. So we want to be careful when we're dealing with these extreme values. We want to be careful with the mean when we do that. Something that is less influenced by these extreme values is the median. And the median is just the middle value. So the median is just the middle value in a set of data. And the key is that that set of data has to be organized in ascending order. Right, so if my data set is 3, 7, 5, 4, 8, 6, 2, I need to order that first. 2, 3, 4, 5, 6, 7, 8. And then find the middle, and I'm just going to do that by crossing off values. So 1 from the front, 1 from the back. 1, 1, 1, 1. This one's left in the middle. My median is 5. If there are two middle values, so the thing we have to watch out for here is that if there are two middle values, just take the average of the two. Right, so if I knocked off maybe this 2, so I have 3, 4, 5, 6, 7, 8. Well, if I start eliminating values, I have a 5 and a 6 in the middle, so my median is really actually the average, which is 5.5. So I'm just going to get rid of this for a second so I have some room. The key with median is that it's what we call resistant. It is resistant to extreme values, which means that it's not easily influenced by those extreme values, unlike the median. I'm calling these extreme values instead of the term you might have heard before, which is an outlier, because not all extreme values are necessarily outliers. We'll talk about what that actually means in a minute. The last one we're going to talk about is the mode, and the mode is just the most frequent value or element in the data set. There can be multiple modes, there can be no mode at all. So there could be one mode, and if that's the case, we call it unimodal. same prefixes like uniform or unicycle. There could be two modes, and we call that bimodal. There could be multiple modes, or there could just be more than two, and we would call that appropriately multimodal. Or there could be no mode at all, and we don't give it a name in that case. Right? There doesn't have to be a mode. There could be many modes. There could be one. There could be none. Whatever. This is typically best used rather, for non-numerical data. Right? If I'm looking at the test scores and maybe 5 students or 3 students, for the sake of writing it, got 100, and maybe these were the other grades, it's not sensical, it's not logical to say that the best way of describing the data is that most people got a 100. An average or a median would be better. But if I just think about like a simple like poll, just like simple voting, the winner is the person that, or the thing that got the mode votes, right? Whoever has the most votes win, and the mode is the most frequent value. These last two pieces of information here are not measures of central tendency. We're going to talk about what they are more in the next section, but they're still important, and I still want to start covering them now. So the range represents the spread of the data. Very simply, the range is just the maximum value minus the minimum value. So sometimes you might see it written as x max minus x min. That's all you need to know about the range. The quartiles are a more specific version of range, I guess would be the best way to say it, and there are actually 5, despite the prefix implying 4. There are actually 5 values that we want to talk about here. We have the minimum, the first quartile, we have the median, the third quartile, and the maximum. And you might be asking yourself, what about quartiles 2 and 4? Well, quartile 2 is just the median, and quartile 4 is the maximum. So when we talk about quartiles, we actually want to include the minimum as well, even though it's technically a 5th value. It's still really important. One thing I also want to talk about with quartiles is we can use the quartiles to calculate outliers. So with quartiles, we have this interquartile range, IQR, and that's calculated by taking Q3 minus Q1. So here is my IQR. And it tells me how spread out most of the data is. Right? Most of the data is going to fall between Q1 and Q3, with some of it sticking out on the edge. And this starts to give me a better sense of how the data is spread out, not just what the data looks like overall. Well, we can use that to come up with an outlier, and outliers are extreme values. Again, not all extreme values are outliers, but enough of them are that we give them the name. And we use the IQR to determine if something's an outlier. So a value is an outlier if it lies more than 1.5 times the IQR away from Q1 or Q3. So if I were to like visualize this, so here's my IQR. I want to go out 1.5 times that, and here's my cutoff point. Anything past there is an outlier. That's Q3, right? And here's Q1, and I'd want to do the same exact thing. Go out way far away, and here's my cutoff point again for outliers. Oops. So mathematically, we would say that an outlier would fall Q1 minus 1.5 times the IQR. So x has to be less than that, or x has to be farther than Q3 plus 1.5 times the IQR. And those are kind of the two boundaries that we set in order to determine if something's an outlier. So I've given you kind of the groundwork here, and in the next video you can start to see with the problem below, right? We're going to start to talk about actually putting this all to good use and actually applying it and working with it.